All right, I just want to show you this. I know there's a better way, but if you look here, I'm taking sine x and I'm making it x. And it's a pretty good approximation. If I add what we discussed in class, so adding minus x cubed over 3 factorial, which is 6, then the approximation gets better. Again, now it's a cubic approximation, or we're using the first two terms of the polynomial to get it. If I add another term, so plus x to the 5th over 5 factorial, which is 120, I even get a better approximation. And again, I can keep going and adding more terms, and I'm going to keep getting a better approximation for sine x. We can do that for whatever we want here. We can make that cosine x. Oops. I guess it wants those parentheses. We can take cosine x. And again, the first order approximation, the zero order, is, look at this. This function and cosine, they're really close at 0. I need to add more. So I'm going to add a quadratic term, x squared over 2 factorial. This is a disaster. X squared over 2 factorial. And now it's better. It's a better approximation of this. I can add plus x to the 4th over 4 factorial, 24. And now it's even better. Look how close this polynomial is to describing this trig function as long as I'm somewhere, probably almost all the way out to 2 radians. 2 radians is like 120 degrees. If I keep adding more terms, it would be better and better. I can take this and make this e to the x. E to the x. Okay, and again, the first order approximation for e was just 1. Look, it's not great. It's not really good at all, right? But it does agree with e to the x at x equals 0. And then let's add an x. And it starts to be better. The next term is plus x squared over 2 factorial. And it starts to get better. The more terms you add in the approximation, x cubed over 3 factorial, the better it gets. Look, if I don't want an exponential and I want a polynomial, I have this thing almost identical all the way from 1.5, maybe from 1 to 1. That's so similar. And I'm building this. The more terms I add, the better and better my approximation can get. I can do this for anything because all I'm really doing is matching all the characteristics of my function to a polynomial. I'm choosing the coefficients of my polynomial so that they have the same characteristics as my function. And my function's characteristics are its y value, its derivative, its second derivative, its third derivative, its fourth derivative. And if I make a match there, and again, these terms controls the function's value. The linear term controls the derivative, the quadratic term controls the second derivative, the cubic controls the third derivative, and I just keep building this. And I can build it at any value I want. I can just shift things pretty easily and start my construction other than 0. I probably can't do most of those in my head, but these e to the x, inverse tangent, all of those graphs you can do. So hopefully you can play around with your graphing calculator and you can check some of your answers, but we're coming up with polynomials that have the same model as a more difficult function.